Hey class, I'm back inside your computer today. I'm here talking about friction. So in our upcoming lab, we have to deal with things with friction. So friction is a force that occurs between two or more surfaces, and you can read that right here. All right, so friction is a force that occurs between two or more surfaces. Friction is dependent on the surface material. So what that means is that different materials have different types of friction. So example, ice is slippery and rubber is grippy. So they would have two different frictions dependent on those surfaces. So friction is always in the opposite direction of the sliding motion of an object and parallel to the surface. All right. So what that means is that when an object is sliding, the friction points in the opposite direction of that sliding motion. Now, friction is used to help us move. So when you walk or you run or you're driving a car, friction is actually pointed with you. And we can explain that more in detail. So it's pointing in the same direction. Friction actually points in the same direction that you are moving in. I'll discuss that tomorrow. There are two different types of friction. We have static friction and kinetic friction. The first one we're going to talk about is static friction. Static friction is present when the object is not moving. It is a building force, also known as the force needed for an object to be able to move. What this means is that a stationary object requires a certain amount of force to be able to get the object moving. For example, let's say a box sitting on the floor requires 100 newtons of force to get it to move. So that means that you need to build up to that force of 100 newtons. So if I apply a force of 0 newtons, then the static friction is also 0 newtons. As you start to increase the force, so does the static friction until you reach 100 newtons. At the point you reach 100 newtons, that's when the object begins to move. So static friction builds to a point. And then once you build to that point and then it begins to move, then you are no longer in static friction. All right? So static friction is only for stationary objects. So what that means is that static friction is actually for Newton's first law. You won't see static friction in Newton's second law. Friction is dependent on two variables, normal force and the coefficient of static friction. Now, the coefficient of static friction is a unitless number and is the ratio of the force of friction to the normal force. The equation is as shown below. It changes dependent on the surface. Ice has a small coefficient, rubber would have a high coefficient. Usually ranges between numbers 0 and 1. So in this equation, we have mu s. So that's the Greek symbol mu. That is the symbol used for the coefficient of static friction. And it's the force of friction static divided by the normal force. All right. And then FFS, force of friction static. That is a force that has a unit of newtons. So the coefficient has no units because it's newtons over newtons, and the newtons cancel out. So therefore, the coefficient of static friction is a unitless number. All right. All right. So the next thing we're going to talk about is kinetic friction. So the other type of friction is kinetic friction, and that is for moving objects, either at constant velocity or accelerating. So you could be either moving at a constant velocity or accelerating. In either one of those, if you're moving, you have kinetic friction. So kinetic friction is very similar to static friction, but it is usually less than static friction. So that means that it requires more force to get an object to move than it does to keep the object moving. So the example I like to talk about is that if you're rearranging your bedroom, right? Sometimes it's really hard to move your bureau or your bed, but once you start moving your bureau or bed, it becomes easier to move. Because what that means is that you broke free from static friction, and then now you are in kinetic friction. It's easier to tell with heavier objects because they're so they're heavier. They have a larger normal force, so it's easier to register their frictions. So just like the coefficient of static friction, the equation for the coefficient of kinetic friction is the force of friction kinetic divided by the normal force. Now, the equations are basically the same thing, but what happens is the coefficient of kinetic friction is usually a smaller number than the coefficient of static friction. That smaller coefficient actually results in a different force of friction. All right, and we'll be exploring these types of ideas tomorrow in the lab. I just wanted to give you guys a heads up, and hopefully that makes sense. And we'll see you tomorrow. Bye.